My name's Ian Mitchell. Previously I did a lightning talk which was just a very quick overview of data warehousing in the space of about 5 to 10 minutes. Craig allowed me to come back today to go into a little bit more depth as to exactly what happens with data warehousing. The format today, I'm going to try and put a little bit of context in it, so it might seem a bit strange to start with, but bear with me, it'll build up into a story. So data warehousing, deep dive. So you wake up at 7, you get your first cup of coffee at 7:30, you drop the kids off at school for 8, you sit in traffic for half an hour, and then you start your work day. And then aliens attack. And they break your favourite coffee cup. And just when all hope is lost, superheroes come along and save the day. But sometimes people get hurt, bones are broken, and heroes fall. So they get private medical insurance provided by a company called Super Health Insurance Excess and Life Division, or SHIELD for short. Okay, our heroes can now afford to get those life-saving surgeries. Woohoo! Okay, so how does health insurance work? Well, you have a group, policy registrations and members. So a group would be the company that you work for. A policy registration is effectively like an identifier of your relationship of your registration with that company, and then members are entered onto policy registrations. So that's the individual customer. A policy registration can be linked to multiple contracts. So a contract is your relationship to that company, to the health insurance company, and that would be active between points in time. So I currently have my contents insurance with Swift, I think it is, and that will be active for a range in time. Contracts are linked to products, so if you have, for instance, private medical insurance or dental care, or with your home insurance you might have your bike and your mobile phone. They might be covered by, and these could be covered by different products, so the product would be linked to different contracts. Within the health insurance company, there would be different agents, different staff that would be supporting the groups. So the companies that were a couple of slides back at the top of the business model, and then those groups could also be split up by different regions. So SHIELD's board of directors have a meeting and they come to one conclusion: they have no idea how well the company is performing. They need management information reports. They need a data warehouse. Okay, so a data warehouse gives them this through 3 different steps. Okay, acquisition. Data is loaded from source systems into a staging database. So you have different source systems for your that you require data from. Now this could be containing the customer information. It could be your HR model. It could be all the different dimensions of data that you need to incorporate together into a data warehouse. Integration. So this is when you take that source data and you would integrate it into a common model. So you are effectively looking to take all the different components from your source data and really present that together in a model that is a structured presentation. So this is when you are presenting the data back to the user. So it's all about how is that data in the integration layer being, how is that consumed by your end users? Because they don't necessarily want to see all of the different groups and policy registrations and members and agents. They'll want to see an aggregation of that data. So how would SHIELD do this? Okay, so let's say that you have Marvel data and you've got DC data. The Marvel data could be structured as shown at the top, and the DC data could be shown structured as at the bottom. So the acquisition model is really about getting that data and just loading that into the database. When it's going into the integration layer, the data would be split out by, we can see here that we've got a Marvel group and a DC group. So under Marvel you've got Iron Man, Black Widow, Captain America. Under DC you've got Superman, Batman and Wonder Woman. And they all have their policy registrations that link them to the groups. When it comes to presentation, it's about taking that information that you have in the integration layer and presenting that back. So business activity is aggregated into a star schema in this instance. So we need to define what our different dimensions are required for modelling for the reports. So in this instance I've taken you should always have a time dimension. We have a product, a movement type, a support agent and a region. So whether it's your region's the geographic location, we have groups which are the employment company, the different products that we talked about before. So movement type is what we're going to talk through in a moment. Support agent is the member of staff that would actually be represented through the model. So we'll go through some different scenarios. So Superman and Lois Lane get married, and he adds her to his health insurance policy. So what would this actually look like? Well, in data terms, on day one, you could have data coming through from DC, where you have Clark Kent, Bruce Wayne, and Diana Prince. And then on day two, there's a new record that exists where Lois Lane has been added, and you notice that where we have PR0006, just down there at the bottom, that's the same policy registration identifier that Clark Kent has. So on day one in the integration model, you would have Superman, Wonder Woman and Batman. And on day two we can see that Lois Lane has been brought to be under the same policy registration as Superman. When it comes to presentation layer, this would be created as having the group dimension would be represented as DC. Time dimension would be the date in which it was actually effective. The product dimension would be his private medical insurance policy. It's the movement type is an expansion, so that's the actual business activity that is occurring. The region is happening in Gotham City. The support agent would be the member of staff, so that's in this instance Agent Simmons. So the data is related through a fact table. So we can see that we have a metric as well that we're tracking. So it's got a volume of 1. Okay, so scenario 2, Scott Summers dies. A spoiler alert for X-Men 2. So his policy registration lapses as a result. So on day one, the Marvel data that we're getting would show that everything is okay, and then on day two, there's an update to his policy registration, and it has an end date. So I don't know if you can see that very well. It's but it's highlighted in red with the 2003-05-01. In the integration model, this would be on day one. It would look like he existed on one day, and the second day he doesn't exist. So it wouldn't necessarily be that he is actually removed from the database. There might be a slowly changing dimension or some sort of end date that would represent the termination of his policy. In the presentation layer, much like the previous instance, this would be added as a record to the fact dimension. So we again have a metric value of 1 for volume on the fact. It's got a different movement type, so his policy has lapsed. This is in New York instead of Gotham City, so it's got a different identifier there. It's still recorded against Agent Simmons, but it's got a different group. which is Marvel X-Men instead of DC, and it's got a different date as well. Scenario 3, new business. Hawkeye gets dental cover from Agent Coulson. So on day 1, our Marvel data represents that Hawkeye, Clint Barton, has a policy registration which has one product against it. On day 2, this is sent into, there's an update that's sent in where there's a second product added against the data. So when it's being integrated into a model, we have a member who has a policy registration which is linked to a contract which has a product. On the second day, this would show that he now has both dental cover and private medical insurance. In the presentation layer, it's much the same as we had before, where we have a date, we have a product, we have a metric, there's a different movement type, we have a new business movement type, there's a region dimension, still the same, New York. It has a different support agent this time, so instead of it being Agent Simmons, it's now Agent Coulson. And the group this time is Marvel Cinematic Universe, so it's slightly, you'll see a difference here in the different records that we're building up. Our final scenario, transfer. So the X-Men join the Avengers. So our Marvel data on day 1 has 2 different groups. They have different identifiers and different members under them. On day 2, we now only have one group for this data. So it's all been consolidated. So on day 1 in the integration layer, you would have Marvel and X-Men looking completely separate. And on day 2, they've transferred across. At presentation layer, we're showing a higher volume this time because it's a mass number. So we have 10 on line 4, and we have 10 on line 5. So we are transferring out and we're transferring back in. So they've transferred out from the X-Men group and they've transferred into the Avengers. So you have the region is still against New York, it's against Agent Simmons again, it's against 2 groups, and it's got the one time dimension, so 2020-04-15. So as more data is collated, the agents, the staff can start to collate this data into slightly better MI, so they'll be able to give their managers better reports and dashboards. To summarise, the source data resides in a structure relevant to a system of record for operational purposes. So your system of record would likely be in OLTP, so it's more about transactional data, about small records. When it's going into your data warehouse, it's about aggregating that information, and it doesn't need to be real time either. Data warehouses tend to have overnight batch processes. The source data, again, is typically normalized to enable integrity and non-redundancy of data. It's efficient for low volume transactional based analysis, gives you real-time results. It may be split over multiple systems. That's a really important thing to keep in mind. In this instance, we had Marvel data and DC data, but there would also be a HR system, so how the agents of S.H.I.E.L.D. were being represented in that system. You might have how the contracts exist. That might come from a separate system again. So all these different sources, they might be perfect for the purposes of what those source systems are trying to do, but it's not necessarily relevant to how it needs to be presented back in a data warehouse. When it's going into the acquisition model, data is landed into tables to allow multiple data types. It needs to be validated. It needs to be records that are changing between one day and another day need to be identified. You should try to avoid doing full data loads as you through all the data every single day. if you can, so the primary key at this point should be relative to identifying an incremental or a delta between day 1 and day 2. So it's not really relevant to the natural business key. It's not necessarily about the account number. It's maybe more about a load ID or a timestamp to identify changes in data. As it goes into the integration model, at that point you would be more concerned about the natural business key. So that's when it's getting into more logical modeling. When it's presented back, you may use star, you may use snowflake models. You might even present it back in a very similar model to how it was taken from source systems. The facts and dimensions might not be relevant to the presentation. It really does come down to what are your requirements, and the consumption is really about your reports that you're presenting when you get to the end of that. So in the past I've used SSRS, but you could also have analysis services. You could have cubes and different. There's different ways of presenting that data back to the front end. Cognos is another technology that you could have based on the any facts and dimensions. And that concludes my presentation. So, has anyone got any questions or anything? Nope.
You say it's generally daily.
It doesn't need to be daily. It depends on what.
Do you think there's a push for getting that up? I mean, looking at global businesses, what's a day?
Well, that's a good point. So with if you need to have downtime. Batches tend to run over periods of time. During that time, your data warehouse may be offline because you don't want to have, depending on what the setup is, but in instances in the past where I've used it, it would be a case of you would have a batch that would happen between 2 a.m. and 4 a.m. or something like that. And the load is churning through that period. But if you're going into a global market, it gets more complicated because at one point, your users might be looking for a snapshot, in the middle of the night for one region, or the middle of the day for another region. So I don't know how to answer your question, but it gets complicated where you start looking at international models.
Yeah, we actually load those 3 times a day, and then we present it to business around the world.
Okay.
And Dr. One gives everything.
Do you?
It was for the performance data, so it's
Okay, so it's
real time.
so it depends on what the requirement is. If your requirement is based on management information reports, perhaps for sales, there might not be. I've not come across. I mean, I tend to work with in financial services where it's about operational usage rather than technology. So the requirement that we had was always about either having daily reports, weekly reports, or monthly reports.
So it makes it much easier.
Yeah, it does. It was it can be a bit complicated with thinking about how you would implement across different batches, and if you get into a T+0 or T+1, how do you integrate those? And there I spoke about having an integration layer. You don't always need that. It's really depending on what the source data looks like, how you would integrate it, and how you present it back. What are the requirements?
So, see when you're kind of talking about the integration layer and stuff like that, would that be when you're performing like the ETL using like SSIS or something, or is that what leads into that?
So you would have different integration strategies. You first of all would need to. I mean, with this model that I've just shown you, you would have an ETL package, perhaps, or an ETL solution to load it into your acquisition layer. You would then have a second means of a second pass over the acquisition data to get that into an integrated model, and then a third one to get it into a final presentation layer.
So really you'd be splitting up the extract, the transform and the load.
Exactly. Yeah, and the different points, as I mentioned before, you're really trying to focus on different elements. So on your acquisition, you're trying to identify the relevant data rows. So I can't stress enough how important it is that any primary key that you're operating from should be based on some sort of identifier. It doesn't matter what the account number is at this point in time. It doesn't matter what the names and addresses and things like that are. It's about identifying, having a means of identifying which records have changed. So if you've got some sort of audit ID or update date that is against an individual record, then those sorts of things are very useful.
Yeah.
When it goes into integration, you're really more concerned about what is the business model, how are we looking to associate all of these records back together, and how can we take the updates from the acquisition and update those, because if you're needing to do a full load every single day, it's very onerous, and it will extend. If you've got tens of thousands or millions of records, then
It's asking for trouble.
exactly. So if you can, as far upstream as possible, if you can reduce your record set, it'll make it a lot smoother downstream for performance.
Is that where you would have probably at the data warehouse level rather than before that? Is that where you'd have partitioning in place where you only really
Possibly. So there's different strategies that you could have under the bonnet. At a server level, you could split out your you could, from acquisition to integration, I would keep the you could have the databases stored on different SANs. You can have a different location for your indexes. Keep your logs separate from your from the data. A DBA will say it wouldn't actually matter how the server's configured at SQL Server level if it's configured properly under the bonnet, going down to the operating system level.
Yeah.
But from a developer's perspective, I think I personally prefer to have an element of control when it comes to configuration. So, and I would split out the temp DB from the data as well. It's just about thinking about what direction is your data moving in, how is it going to, where are you going to end up getting bottlenecks.
Yeah. Like I said to you before, I'm studying for the MCSE just now, and it's the BI solutions part, and it's like touched on data warehousing years ago, and it's a lot of the examples and stuff I'm going through, like the material I'm kind of working from, is all quite high level. So just seeing the examples of when you're kind of showing the data changes and how that changes through each level and what you're doing with it and things like that really helps to kind of add a bit of context to it.
Yeah. So that's all I was looking to do today, was to give you a wee bit of context about some examples. But honestly, the data warehouses change. No tool will be the same, because they'll all have different requirements, different source data. You'll have some systems will have legacy source data, trying to combine it with a modern system. So they're all different.
Unstructured data in your data warehouse.
Sorry?
Unstructured data in your data warehouse. You just try and apply structure.
Well, in this example, I was structuring it. You wouldn't necessarily even need to, but it depends on what the source data looks like. If you have an example where you're trying to combine multiple data sets together, it might make sense to structure it. If you're working with, I'm guessing everyone here is from SQL Server, but if you're in a Teradata world, there's something called the FSLDN. They have a common data structure that is applicable to that you can apply to 95% of financial services data models. But it depends on what the source data looks like. If your source data is coming from one source, if it's already very well maintained, it's clean data, you might not need an integration model. You might not need to model it at all.
I would have said that as storage has become cheaper, then it's become an exercise in extract, load, then transform, because you just put everything in and let people decide what they want when they want it. Just don't actually scrub anything out, let it exist as long through the process as you can. Well, sometimes some extra value by being able to actually say, well, you don't have to rework processes to get more information.
But
sometimes
I agree with you in theory, but at the same time, I come across a lot of instances of badly defined requirements where they just decide that they want everything because they don't actually know what they want. But it's. I'm not saying that there's not an argument for it. It's that there absolutely is, if it's the right, if it's for the right reasons. So.
I think, just to kind of build on what you're saying there, I think the biggest problem, or the thing that is coming up in a lot of the theory stuff that I'm reading, is the worst thing you can do is not get enough, like aggregate too much at the beginning or something, or not bring through enough, and then it causes all sorts of problems, and you're having to kind of cycle back and rebuild everything again.
Yeah, if at the presentation point, if you try to give them 10 million rows of data, how are they actually going to use it?
Yeah.
Right, so they could end up actually writing you could have a end user who has a little bit of technical skill. He writes a report that is actually just extracting all of the members and all of the groups and all the policy registrations, and all of a sudden you don't have a report, you've actually got a data extract. And they'll chuck it into Excel, they'll put some filters on, and some pivots and things like that to try and get what they want, but really they end up getting something that's quite slow because it's not been it's not gone through a proper ETL process. Had it been presented to them as perhaps a star schema, they might be able to present that data back. So it depends where it is your requirement. At what point are you doing handover to the business, to the end user, for them to define what the requirements are, or should it be formalized to developer?
Yeah.
So
I mean, I've worked with from more of a user perspective, because the business units were quite separate. But when I was a developer quite a while back, I was working with a data warehouse that was built by a whole separate business unit, and they'd already aggregated quite a lot of data, and we were reaching the problem where stuff that we were able to get right down to the bottom of, to kind of cross-check and check numbers and things like that, we couldn't get all the way down because they'd already sort of summed up each hour, say it was phone records coming through, they'd put summaries already in the data warehouse level, and it's that's us screwed for verifying this or weeding out problems, or if we want to look at specific records and things as well. So.
Yep.
Then you can get to different presentation layers, and you can have a presentation layer that's got raw data.
Yeah. And I think that the problem that we came across, it's one of those things where I didn't know enough at the time, but looking back, I think they'd already aggregated it from the source databases going into the data warehouse. So it's unless we just scrap the data warehouse and go straight back to the source databases, you're never going to get that kind of thing, which I guess is one of the worst things for a project like that. If people aren't going to use the tool we created, then what's the point?
Okay.
Cool. Yeah, cheers. Thanks a lot.